Hello guys, just in case I owe you my name, this is Mr. Damoza and I'm a teacher in one of the schools around Umtata. I have created these questions just to create your curiosity around the geometry of lines. We have this Cartesian plane, just a normal Cartesian plane, 0, 90, 180, 270, should be 360 there. Now, there is a question asking us why x-axis and y-axis are not perpendicular to each other. Are they perpendicular or not perpendicular? According to our idea, we know that they are perpendicular to each other because from here to that side, it is said to be 90 degrees. So now this knot alone is taking away the idea on how to understand the word perpendicular. Now, I say they are not perpendicular to each other. In fact, let me just wrap this thing. They are not perpendicular to each other for a certain reason. Why do I say so? According to the way I understand how to prove the perpendicular lines. Let's say I have this point A for a strange reason. I have point B for an anonymous reason. Let me say A is 2. Here I have 3. And the coordinates of A is going to be 0 is to 2. And the coordinates of B is going to be 3 is to 0 in this case. Now, let me find, and this one is O, let me find the gradient of what? Of O, FOA, and the gradient of line OB, of line OB. Now, I need to find this gradient of these lines. Now, what I have, the gradient of OA, this is just a vertical line, it is undefined, guys. And the gradient of OB is just a vertical line, it's just a horizontal line, and the gradient is equal to 0. According to the idea of perpendicular lines, the product of their gradient and the product of their gradient is equal to -1. And then, so is this line, is the gradient of this line times the gradient of this line equal to -1? I don't think so. Undefined times 0 can never give me -1. But how do you then prove this thing? By understanding this theory of proving perpendicular lines. Let me use the contradiction. The proof by contradiction that these two lines are not perpendicular lines. When you contradict, which means this is not what it should be, or this is what it not should be. Now, what we have, let's assume that gradient of OA times gradient of what? Of OB is equal to -1. Guys, this is not true. This is just a false statement because we know that undefined times 0 is never be equal to -1. So this is just a false statement. But let's just assume that it appears that way. That is a false statement. And if that is the case, let's substitute the gradient of OA is what? The gradient of OA is undefined, guys. And the gradient times the gradient of what? Of OB. OB is what? It's just 0. Then you get what? -1. So this is what is continuing with the what? With the false statement. Let's get an idea. Let's solve the what? This undefined by dividing by 0 both sides. By dividing by 0, this 0 cancels this one. Undefined is equal to -1 over 0. Anything divided by 0, guys, is undefined. So in this case, undefined is equal to undefined. Is that not true? Undefined is equal to undefined. That is true. 1 is equal to 1. That is true statement. So from false statement, we get a true definition of false statement. So this implies that whatever that we are calculating that was false, this true is regarded as false because the true assumption or the true assumption can never lead us to the false statement. or the false assumption can never lead us to what? To a true statement. Because we got this through, which goes by the what? By that false assumption, which means this is therefore the what? The line OA is not perpendicular to what? To line OB. And then this is not perpendicular to line OB by that case, because now this is giving us true, hence we had what? A false assumption. It has to give us what? Another false statement in the what? At the end of the calculations. So by that one, we say OA is not perpendicular to what? To OB. Because of that, this is the proof by contradiction, by saying what? No, it is not. Make it as it is. And then, so this is what we have done here, and continue to get the true statement from the false statement. That is why our conclusion should be following the idea of the opposite of the assumption. Hence, we are contradicting with what? With the generalization of the method. Now, after that, I can say now these lines are not perpendicular to each other. They are not perpendicular to each other at all. So you can use any way to prove your assumptions as well. Otherwise, this is the way I understand that these x-axis and y-axis are never perpendicular to each other. So in that case, I rest my case, and I want you to go for your curiosity and find a way in proving whether these two lines are perpendicular to each other. Or if you have already done that, you can just project it, or I'm just waiting for any views. You can post a comment. Guys, can you please, if you are watching my videos, can you please subscribe so that whatever video I'm posting, you get updated and be able to find it on time. So for that matter, that's just the end of my proof that way. Thank you, guys.